Hey guys, so this is a quick video to help supplement some of the stuff that you're doing in Edmentum. I know that there's a tutorial. I know that they give you some explanation, but I'm going to see if I could explain it in a little bit clearer, more concise, hopefully simplify it a little bit. Edmentum is using a lot of fractions within fractions, so we want to see if there's an easier way that I can show you how to do things. Additionally, what's nice is some of the stuff we already covered. Proportional relationships as far as identifying them from a table as well as graphing them, we already covered. So I'm going to review that as well. The latter half will be a review. So that if it seems familiar, it is. So a little bit of a review, pause as you need, just a little bit of something extra in case Edmentum itself wasn't quite cutting it for you. Before we get into proportions and all that great stuff, it really helps to kind of backtrack a little bit and talk about a thing called ratios, something that you guys should have covered already last year. What a ratio is a comparison of two numbers by division. There's three ways we can write a ratio. We write it using the colon, the little two dots. We write it as literally the word two, T-O, or we write it as a fraction. Of these three ways, this is the way we're going to use most often because we can add, subtract, multiply, divide, and simplify fractions. In any event, though, they're all said the same way. A to B, A to B, and A to B. If we talk about expressing the ratio as a fraction in lowest terms, we're simply being asked to take this fraction, 15 to 10, writing it as 15 to 10, and then simplifying the fraction. What goes with both 15 and 10? 5, of course. 5 goes into 15 3 times. 5 goes into 10 2 times. So if I say to you that, and this is again what a ratio is, for every $15 that you earn, someone else earns $10. That is the same as you earning $3 for every $2 that they earn. Again, if we want to label this out and kind of list it out, if I got 3 for every 2, on the next one, if you got another 3, in other words 6, the next person will get 4. Now if we continue this pattern, 3 more, 2 more, 3 more, 2 more, so 2 more than 6, 8. 3 more, 15, 2 more, 10. You'll see that 15 to 10 is the same thing as 3 over 2. We've done this, we've looked at tables, and we've noticed that there's a relationship between, let's say, an X and a Y. It's how many that you get compared to what you get. When they have the same value, they're called equivalent ratios. So we just made an example of equivalent ratios. 15 over 10, we decide is equivalent or equivalent to 3 over 2. Now, one neat fact you could always tell about this, in order to determine if they're equal, there's three ways to do it. You can simplify the fractions. We've talked about this. You could turn them both into decimals. You could divide. 15 divided by 10 is 1.5. 3 divided by 2 is also 1.5. It makes sense because they are, as the equal sign implies, both equal. But the other thing, and this is the one that we definitely need to know, and this is going to be the most helpful thing for this unit, cross multiply. In a proportion, which we'll get to what a proportion means, but if you have two fractions that are equal to each other, if you cross, so I go across from upper right to lower left and then vice versa, and we multiply, 3 times 10 is 30, and 15 times 2 is also 30. That will work for any two fractions that are equal. And that's really the key to this whole thing, is if you cross multiply, you know that you'll get the same number. That'll help us in just a little bit. Now a specific type of ratio is what's called a rate. A rate is still a comparison of two numbers, because that's what a rate is. But a rate always has different measurements. Miles an hour measure different things. Miles measures distance, length, and hours measures time. So miles per hour is a rate that you should be very familiar with. It's also known as speed. Dollars per pound, dollars measures value, and pounds, I know that we could talk about the English measurement of value, but pounds measures weight. So value and weight. These are all examples of different types of rates. A unit rate is one that we are going to see quite a bit. A unit rate is a rate where the denominator is 1. The reason we talk about denominator as 1 is because if you had and you did this in 6th grade in typing class, if you were to do I could type 84 words in 2 minutes. They want to know how many words per minute you can do. Not words per 2 minutes, words per minute. So if you could do 84 words, and notice that I'm labeling, you know how I feel about labeling, 84 words for 2 minutes, to figure out how much you could do in 1 minute, all you have to do is, there's another way I'll show you later, but you just have to divide. 84 divided by 2, that's 42 words per 1 minute. That's called a unit rate. How many, where the denominator is now 1? How many words per 1 minute? So this would be 42 words per minute. If it's $10.75 for 5 ounces, again, that's $10.75 for 5 ounces. And we want to know how much for just 1 ounce. Again, the denominator or bottom of the fraction is 1. We just divide 10.75 divided by 5, which would be $2.15 per 1 ounce. $2.15 per 1 ounce is the same as $10.75 per 5 ounces. So any of these word problems that are asking you to do things like that, you're simply looking for the unit rate. You're going to divide on most of these types of questions. That number is called the constant of proportionality. It's also known as the slope, and we'll get into that a little bit more. But essentially, on any one of these problems, if you're trying to find out the better buy, you want to find out what's called the unit rate. So it's $7.50 for 10 pounds. So how much would it be for just 1 pound? Because we want to know how much I'd pay dollars. Notice that I'm labeling dollars and pounds for 1 pound. This would be 75 cents when you divide per pound. Down here, it's $8.52 for 12 pounds. Notice that again I would label. And to find out how much it would be for just 1 pound, what I would have to do is I would have to use your calculator, 852 divided by 12, and you would get $0.71 per 1 pound. So which of these is the better buy? 75 cents per pound or 71 cents per pound? Well, since you're buying it, you want to pay less, and so that 12-pound bag. In general, when you buy more, you get a deal. That's why Costco sells things in bulk, and we tend to get a better unit price. The actual price is more, but the unit price is less because you're getting rewarded for buying so much. Next time you're at the grocery store, there's always a price tag. It says $2.50. But if you look underneath, it'll say $0.03 or 3 cents per ounce. And you might look at the next one and it might say $3.10. So you might say, well, $2.50 and $3.10, that's cheaper. But if you look at this one, it'll give you the unit price is 0.02 per ounce. And then you'll know that 2 cents per ounce is cheaper than 3 cents per ounce. So you get that one. Those are things to consider when talking about proportions. Now that leads us to proportional relationships in general and identifying the different aspects of it. We talk about proportional relationships where there's a ratio of one quantity to the other and it's the same one. We see it in the form y equals mx. M is a constant. We'll plug a number in there. And that value is the relationship between y and x, the two things that are varying or changing. Slope, as we've talked about, is change in y over change in x. So you can just count up and count over. That is a review. If we want to determine the slope or the constant of proportionality, as was mentioned, we plug in, we know that's x and y, and that's x and y. And you'll see a table, 2 for my x, 4 for my y, and then 3 for my x, 6 for my y. You'll see that from here to here is +2, but from here to here is not +2, it's +3. So we're not adding the same thing, but if you notice, from here to here we are multiplying times 2 and then times 2. So since we're multiplying times 2, that 2 is the number that goes there. That's called the constant of proportionality. It's saying Every time we have that, x times 2 is equal to y. So every time we have y, that's equal to double x. Now I put the 2 out front because it's the community property. Here are some more tables that we could show you the same example. Y is equal to, well, how do I go from 1 to 3? That's times 3, multiply by 3, multiply by 3. So if you notice, if I multiply by 3, that's what equal to y. Y is equal to 3 times x. So I write down here, y is equal to 3 times x. 3 is called my constant of proportionality. From here to here, we want to make them equal. To go from 4 to 2, we actually multiply by a half, or divide by 2. And again, we multiply by a half. So if I do half of x is equal to y, that's my constant of proportionality, y is equal to 1/2 x. If I graph this guy, I have x and y. X is 1, 2, 3, 4. Y is 1, 2. So I do 4, 2. I also have x is 6, so 4, 5, 6. And then y is now 3, so 6, 3. You'll notice that I go up 1 over 2, rise over run, up 1 over 2 is why it's 1/2. Up 1 over 2. Up 1 over 2 is the same number. So you can always count also. Here's an example showing you the same thing. You could just count. The slope, y equals the number m, it's going to go right here, times x. You could just count. Rise over run. It rises 2, runs 1. Up 2, over 1. Rise 2, over 1. 2 over 1 is the number that I put right there, y equals 2x. Anytime you see these, you'll notice that all of them go through the origin. That's not a coincidence. All proportional relationships have to go through the origin. They have to go through the middle. Otherwise, they're not proportional relationships, y equals mx. So if they don't go through the origin, you can immediately say they're not proportional relationships. Here's a word problem. Miss Baker is paid $3 every 2 minutes. So let's graph that. So let's say this is time is almost always here on my x. So this is minutes. This time, like you see on graphs, goes left to right. And dollars is almost always my y. So I'll put dollars here. So $3 goes up 3, and then 2 minutes over 2. And I know it goes to the origin. So it's up 3 over 2. Y equals up 3 over 2. You also could have made a table where you know that if it's x is putting x as my minutes, as y as my money, so 3 and then 2. So if I double that, that's 4 and then 6, and then double that, or add 2 more. So I go plus 2, 2 more, 6. Keep adding 3, that's 9. Keep adding 3, that's 8, and that's 12. And you could, of course, divide. Y divided by x, y is on top, 3 over 2, which is the same thing as 3 over 2. So to sum up, the main takeaway is you need to know that a ratio is a comparison of two numbers by division. We're doing a lot of ratios. We're comparing two values. You will know a ratio because it'll be written most of the time as either a fraction, and you may see it in table form. They're going to show you a lot of table forms to show you your ratio. Ratios are equivalent if it's the same relationship every single time. The best way to determine that relationship is in the table that you're given. You can divide and see if you get the same number. Now, there are other ways to determine a relationship by adding or subtracting, but for this particular unit, they're always asking you to divide. So if you divide, 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 and divide, and get the same number all 5 times, in this case 5, you have a table that is correct. If you divide and get different numbers, they're not the same relationship. If on one of them you get 1.5 and another one you get 1.5, you at least know that those two are equivalent. In this situation, when you divide, you get all the same number for all of them, which means the entire thing is a proportional relationship. You also should know that a unit rate is a rate where the denominator is 1. So in order to find the unit rate, it's as simple as dividing. Here's a tip for you. Dollars almost always goes on top. So if you're doing a problem and you see dollars, put dollars on top. 5 ounces, and you simply have to divide 10.75 divided by 5 to get the amount of money for 1 ounce. And then you can compare if you have multiple examples, such as this one, you can just divide money divided by pounds, money divided by pound, remember money's on top. So 750 for 10 pounds. And then you could divide 852 for 12 pounds. And see what you get, and you can compare. The other thing you need to know is a proportional relationship can be demonstrated by a table where it's the same thing every single time. We spend time in class figuring it out by dividing, by multiplying, but you could just divide. 4 divided by 2, 6 divided by 3, we got the same number each time. If you divide on any other table, 3 divided by 1 is 3, 6 divided by 2 is 3, 9 divided by 3 is 3. If it's the same number again, you have a proportional relationship. You'll also know because all proportional relationships have to go through the origin. They're straight lines that go through the origin.